students, welcome to the lecture number 10 of chapter 6. In the two previous lectures we have discussed that whenever a transversal line intersects two lines at two distinct points, then as a whole 8 angles are formed. Right? Here if we have two lines AB and CD, then another line PQ, which is known as transversal line, intersect these two lines at two distinct points O, P. Then as a whole, how many angles are formed? 8 angles are formed. And what are the name of the angles? The name of the angles are exterior angles, interior angles, vertically opposite angles, corresponding angles, alternate interior angles, alternate exterior angles, co-interior angles, and finally co-exterior angles. Understood? So these are the 8 types of angles formed whenever a transversal line intersect two lines at two distinct points. Then one question arises here. Okay, what is the question? The question is that whenever a transversal line intersect these two lines, then these two lines may be parallel or these two lines may not be parallel. It means the two lines either parallel or they will intersect. Like this. See, either there is a condition that whenever the line PQ intersect two lines AB and CD at two distinct points O and, sorry, this is not P, this is M, at O and M, then two conditions arise. First condition is that these two lines may be parallel, and the second condition is that these two lines may not be parallel. They are not parallel means what? They will meet each other at some point. Like this. Suppose this is AB, okay, and this is CD. Then another transversal line PQ intersect these two lines at two distinct points O and M. Then as you can see, these two lines are not parallel. They will meet each other at some point if we extend them. But here in this case, these two lines are parallel. If you extend them in any direction, they will not meet each other or they will not intersect each other. Now, we will consider or we will discuss about this condition. What is the condition? The condition is that whenever a transversal line intersects two parallel lines, then what are the angles formed? Okay, what is the relationship among those angles? We will discuss about that concept in this lecture. Okay, so let us start with the first concept, that is whenever the transversal line intersecting two parallel lines. Here we have two parallel lines, then we will discuss how many angles are formed and what are the relationship between them. Okay, so let us draw a transversal line intersecting two parallel lines. Okay, so suppose there are two parallel lines AB and another line CD, and transversal line PQ intersect these two parallel lines at two distinct points. Suppose this point is M and this point is N. Then how many angles also formed here? Here also we have how many angles? 1, 2, 3, 4, 5, 6, 7 and 8. Here also we have 8 angles. Okay, so name them 1, 2, 3, 4, 5, 6, 7 and 8. Now we have to identify the name of those angles. As we know, whenever a transversal line intersects two lines, total 8 angles are formed. And what are the names? The first angle is known as, or the first type of angle is known as exterior angles. Okay, so here the exterior angles are 1, 2, 7, 8. 1, 2, 7, 8. Right? Then next is interior angles. The interior angles are 3, 4, 5, 6. Okay, 3, 4, 5, 6. Next is vertically opposite angles. We know there are how many pair of vertical opposite angles? There are 4 pair of vertical opposite angles. 1, 3, 1, 3, 2, 4, 5, 7 and 6, 8. There are 4 pair of vertically opposite angles. Right? Next is corresponding angles. So identify them. See, angle 1 and angle 5 are corresponding angles. So 1, 5, this is one pair. Then 8 and 4, this is second pair. Or you can write 4 and 8. Next, angle 2 and angle 6, third pair of corresponding angles. And angle 3 and angle 7. So here also we have 4 pair of corresponding angles. Next is alternate interior angles. Okay, so let's find them. Alternate means opposite side, interior means inside or in between these two lines, two parallel lines. Okay, so 3 and 5 are one pair of alternate interior angles and 4, 6 are another pair of alternate interior angles. Understood? Next is alternate exterior angles. So the pair of angles should lie in the exterior side and in the opposite side of the transversal line. 2, 8, 2, 8 and 1, 7. Okay. Next thing or next angle is co-interior angles. Okay. So 4 and 5 are co-interior angles. Or 3 and 6 are also co-interior angles. Right? Last thing is co-exterior angles. Here the angle 1 and the angle 8 are co-exterior angles. This is the one pair of co-exterior angle. Another pair is angle 2 and angle 7. Angle 2 and angle 7. So here we find that whenever a transversal line intersects two parallel lines, then 8 types of angles are formed. Okay. Now we will discuss about one more thing that is most important in case of parallel lines, that whenever out of 8 angles are formed, then out of those 8 angles the corresponding angles are equal. What is it? In case of parallel lines, whenever a transversal line intersects those two parallel lines at two distinct points, then the corresponding angles formed are equal. Okay, I am writing this statement here. When a transversal line intersects two parallel lines. Okay, then how many corresponding angles are formed? 4 pair of corresponding angles are formed. Then those 4 pair of corresponding angles are equal. Okay, then 4 pairs of corresponding angles are equal. You have to keep in mind this statement. Okay, so here angle 1 and angle 5 are corresponding. So you can write angle 1 is equal to angle 5. Similarly, angle 4 and angle 8 are one pair of corresponding angles. So angle 4 is equal to angle 8. And angle 2 and angle 6 are also corresponding. So angle 2 is equal to angle 6. Angle 3 and angle 7 are also corresponding. So they are also equal. Right? So whenever a transversal line intersect two parallel lines, then totally 4 pair of corresponding angles are formed and all the pairs are equal. Okay, 1 is equal to 5, 4 is equal to 8, 2 is equal to 6 and 3 is equal to 7. And this statement is known as axiom number 6.3, right? As we have already discussed about axiom 6.1 and 6.2 in some previous lectures, and this is the axiom number 6.3. Since it is an axiom, it means it doesn't need to be proved. It doesn't need the help of others to be proved, as it is a self-proven statement. We have to remember this statement, right? So axiom 6.3 tells you that if a transversal line intersect any two parallel lines at two distinct points, then the 4 pairs of corresponding angles formed are equal. Right? This is the axiom number 6.3. Now we will discuss about another statement which is just opposite of this statement. So let us understand what is the second statement. Okay. So the second statement is also an axiom. Okay. And that is known as axiom number 6.4. Axiom number 6.4. As I have told you that axiom 6.4 is just opposite, just converse of this statement. According to the 6.3 statement, if the lines are parallel and in transversal line intersect them, then corresponding angles are equal. But here it says that if corresponding angles are equal, then the two lines are parallel. Right? So the statement is, if a transversal line intersect any two lines, here it is not mandatory that the two lines are parallel. No, simply the transversal line intersect any two lines, right? And if the corresponding angles formed are equal, then the two lines are parallel. This is the statement which indicates the axiom number 6.4. So according to the axiom 6.4, if there are two lines, it is not mandatory that these two lines are parallel. No, it is not given in the statement. Any two line you can choose. And another transversal line intersect these two lines at two distinct points, suppose O and P, right? And the two lines are AB, CD, and the transversal line is PQ, right? Then whenever this transversal line intersect any two line AB and CD at two distinct points, then the corresponding angles formed, how many corresponding angles formed here? 4 pair of corresponding angles formed, right? Suppose name them. This is 1, this is 2, this is 3, this is 4, 5, 6, 7 and 8. So here if 1 and 5 are equal, if 4 and 8 are equal, if 2 and 6 are equal, and 3 and 7 are equal, then you can say AB line is parallel to CD line. Okay, so then you have to write, then AB is parallel to CD. Okay, so here this is the condition, right? And this is the result. Due to this condition, this happens. But in the exam number 6.3, the condition is that the two lines are parallel. See, whenever a transversal line intersects two parallel lines. Okay, here the condition is that the two lines are parallel and the result are all the corresponding angles are equal. But here the condition is all the corresponding angles if equal, then the two lines are parallel. So both axiom 6.3 and 6.4 are just opposite to each other. So they are known as converse axiom. Okay. So axiom number 6.4 is also known as converse axiom 6.3 or axiom 6.4. Understood? This is the statement of axiom 6.4 and this is the statement of axiom 6.3. So if you want, I will tell you again both the axiom 6.3 and 6.4. According to the 6.3 axiom, it is given that if two lines are parallel and another line is transversal to it, okay, then how many corresponding angles formed? 4 pair corresponding angles formed. 1, 5, 4, 8, 2, 6, 3, 7. So all the corresponding angle pair formed are equal. This is the axiom number 6.3. Understood? Now, according to the axiom 6.4, what is that? That is given that if a transversal line intersect any two lines, then if this condition satisfied or if all the corresponding angles are equal, then you can write this line is parallel to this line. Okay? Then you have to write AB is parallel to CD. Okay? So this is the simple difference between 6.3 and 6.4. Both are converse to each other, right? One is the condition, another is the effect or result. Here this is the condition, this is the result. Here this is the condition, this is the result.